Hello students, welcome to my channel CGAT Maths. Myself, Dr. Suresh Biradar, Associate Professor, Department of Mathematics, Faculty of Engineering and Technology, Campus University, Calgary. In this video, we discuss an example based on linear partial differential equation of first order. It is in the form of capital P into small p plus capital Q into small q is equal to R, where capital P, capital Q, capital R are functions of x, y, z, is called Lagrange's linear partial differential equation. How to solve Lagrange's linear partial differential equation? First, we are going to construct auxiliary equations or subsidiary equations, that is dx by capital P is equal to dy by capital Q is equal to dz by capital R, and we need to solve these equations by taking two ratios at a time. So let the independent solution of these subsidiary equations are u of x comma y comma z is equal to c1 and v of x comma y comma z is equal to c2. Then the solution becomes phi of u comma v is equal to 0 or u is equal to f of v is the required solution. Now let us solve one example based on Lagrange's linear PDE. Solve P tan x plus Q tan y is equal to tan z. So you compare this equation, compare with capital P into small p plus capital Q into small q is equal to capital R. Then capital P becomes tan x, capital Q becomes tan y, and the capital R becomes tan z. First, we are going to write the Lagrange's auxiliary equations. The auxiliary or subsidiary equations are dx by t is equal to dy by q is equal to dz by r. Now substitute here dx by capital P. Capital P is tan x, dy by tan y, dz by tan z. Just substitute the value of P, Q, R. Now let us take first and second ratios. By taking first and second ratio, take first and second ratios. Dx by tan x is equal to dy by tan y. Now write the reciprocal of tan x is 1 by cot x. Cot x dx is equal to cot y into dy. Now on integration, integrate this. On integration, so what will get? Integration of cot x into dx is equal to integration of cot y into dy plus constant of integration, that is c1. or you can write C1 as log of C1 because integration of cot x is log of sin x is equal to this is log of sin y plus log of C1. So you will get to transform log of sin y to left side, then it will become log m minus log n. So then it will become log m by n, log of sin x by sin y is equal to log of C1. Then C1 becomes, which implies C1 becomes, or you can write in the reverse order, sin x by sin y is equal to C1. Similarly, you can take second and third ratio. Take second and third ratios. That is dy by tan y is equal to dz by tan z, or it is same as cot y into dy is equal to cot z into dz. On integration, integrate this. On integration, so it will become an integration. It will become integration of cot y dy is equal to integration of cot z dz plus log of c2. So it will become integration of cot y is log of sin y is equal to log of sin z plus log of c2. Then it will become sin y by sin z is equal to c2. By transforming log of sin z to left side, then it will become log m minus log n. Log m minus log n is log m by n. Log of sin y by sin z is equal to log c2. Then sin y by sin z is equal to c2. So observe student, this is like u of x comma y comma z is equal to c1. This is v of x comma y comma z is equal to c2. Therefore the solution is you can write phi of u comma v is equal to 0 or u equal to f of v. So I will write first one, that is phi of u is sin x by sin y. This is sin y by sin z is equal to 0. So this is the solution. Now let us discuss one more example based on Lagrange's. Solve zx p plus yzq is equal to xy. Now just compare as I expressed in the first example. This is equivalent to capital P into small p plus capital Q into small q is equal to capital R. Then capital P is equal to zx capital Q is equal to YZ, capital R is equal to XY. Then Lagrange's subsidiary equations are, auxiliary equations are, auxiliary equations are dx by p is zx is equal to dy by q yz, dz by r is xy. Take first and second ratio. Okay. That is dx by zx is equal to dy by yz. Okay, both side z and z get cancelled. You will get dx by x is equal to dy by y, and integration of dx by x is equal to integration of dy by y plus log of c1. Now you will get integration of 1 by x dx is log x plus is equal to log y plus log of c1, or this is log of x minus log y is equal to log c1. Log m minus log n is log m by n, x by y is equal to log of c1, or simply x by y is equal to c1. Okay, now let us take other two ratios, that is take second and third ratios. By taking second and third ratio, dy by yz is equal to dz by xy. Now here y and y get cancels. So what is remaining here is dy by z is equal to dz by x. But you can't solve this equation, this differential equation. So for that, we are going to make use of the first result, that is x equal to, I am going to substitute it as c1y. Okay, I'll substitute x value here, that is dy by z, right as it is, equal to, this is dz by c1y. So now the variables are separated. c1y dy is equal to z into dz, or integration of c1y dy is equal to integration of z dz plus c2, constant of integration. c1 into integration of y is y square by 2 is equal to z is z square by 2 plus c2. Okay, fine. Further, let us substitute c1 value. c1 value is x by y. Okay. X by y into, this is y square by 2, right as it is equal to, or z square by 2 plus c2. 1y get cancelled. X into y is xy by 2 minus z square by 2 is equal to c2. So C1, this is U is equal to C1. This is V is equal to C2. Therefore, the solution is phi of U comma V is equal to 0, or U is equal to F of V. So phi of U is x by y, V is xy by 2 minus z square by 2 is equal to 0, or you can also write in the second form also, or U is equal to x by y is equal to f of xy by 2 minus z square by 2. That's it. This is the solution of second example. Students, if you find any difficulty in this Lagrange's PDE, you can feel free to comment. Okay. Thank you so much for watching.